Hello all, welcome to Coda. Today let us solve the lead code series challenge and the problem is make the string great. Given a string S of lowercase and uppercase English letters, a good string is a good string which doesn't have two adjacent characters S of I and S of I plus 1 where I lies in the boundary and S of I is a lowercase and S of I plus 1 is the same character but in uppercase and vice versa. So to make the string good, you can choose two adjacent characters that make the string bad and remove them. You can keep doing this until the string becomes good. So hope you understand the problem. I will give an example though. So this is our example one where this is problem. As you can see that this two characters I and I plus 1 has a character same and one is lowercase and one is uppercase. So basically when we remove that two characters it becomes LEETCODE and this is our required answer. So for example 2, basically the question is uh, the string is ABB and ACC. So when we remove these two characters and these two characters, the string becomes AA. And again, this also satisfy our condition. So when we remove this character, it becomes an empty string, and this is our required answer. So hope you understand the problem. So how can we solve this problem? It is very simple. We can use an extra space of stack, and using an extra space stack, what we can basically do is we can just check with the top character, and if it is satisfying our condition, we can basically remove that character. So what we can do is we can first do a drive example for the example 2. So ABBACC. So when we here we notice that the stack is empty, so we can put the character A, and we can where the top character of the stack is not the same as the current character, so we can push B. And while we are pushing capital B, as you can see the top character is lowercase and the same character, so we can basically pop that top of the stack. And then again the next while pushing the next character capital J, the top character is small lowercase small a, so we can basically pop that current character in that stack. And then the stack is empty, we can push the small case C. And then when we are encountering capital C, we can just it is same lowercase as the top of the stack, so we can remove that character. And finally the characters that are available in stack, basically we can pop them and we can reverse them and form our string. So this is our stack approach. Here the time complexity will be order of n and the space complexity is also an order of n. If we are not using if we are not editing any characters, it basically boils down to order of n. So how can we do this better? So can we reduce our space to order of 1? Instead of using a stack, can we do that in our given string itself? So yes, we can do it. So let us see that approach, because the stack is very simple. So modify the given string itself, modify the given string. So what we can do is we can have a current pointer which is at index 0, and we can have a end pointer which is at index 0. So basically why we are doing is we are actually modifying the string as it is, so on the go. So let us take the example 2 itself to for better understanding. So as you can see that this character at current and end is not the same. So what we can basically do is we can just move a step ahead. So we can just do a cut pointer plus plus, and before doing cut pointer plus plus, we have to put the character in that end of the in that index end. So we can actually add that end. So s of end is equal to s of cut, and then we can add the current character. If not satisfying the condition, so what we can actually do is we are having the string a. if we are having a character A, and here the current pointer alone incremented. So basically what we can do is we can add this character, and then next when the end is greater than 0 alone, and the if 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 my end is greater than 0 alone, and if my s of end is equal to my s of n minus 1, the previous character before that is equal to my s of char, is equal to s of char, in the sense in our case one is lower, one is upper, one is upper and one is lower, vice versa. Consider in that case we will be having this condition, but for now I will be saying like this: if that is equal, then what we can do is we can just decrement our end minus end, because that is because that character should not be included. We are actually removing that character. It is actually satisfying our condition for bad string. Else what we can do is we can just append that particular character at the end position. So s of n is equal to s of char, and what we can do is we can just increment our end pointer. So this is basically what we can do here. So the char pointer will be moved to the next index, and as you can see that b and B and A is not same, so we will be adding B, and then the end will be incremented. And as you can see that when we add this particular uppercase B and it satisfies this condition, so we basically remove this by moving our end pointer back. So we have moved our end pointer back again, so end will be at position 1, and this is at 0th position. And again the current n minus 1 character is equal to this uppercase a character. So again this end will be moved back, and end will be pointing at position 0. Till now we have not included any character at that particular index. Again that c will be added here, and we will move our end to here, the next pointer. And when we add this particular uppercase a, as you can see that it satisfies our condition, it is equal to the smaller case c. So we basically move decrement our end pointer, and finally we can just return the s dot sub str of 0 from 0th index to the end. So we can just remove. So we basically modified the current given string itself. So here the time complexity will be an order of n, and the space complexity will be an order of 1. So what we can do is we can take the size s dot size, and we need a char pointer. So what we can do is we can need an end index, and finally we are going to return s dot sub str of 0th index till end it should take. And now we can just have a char pointer for int char equal to 0 till char less than n and char plus plus. What we basically do is if my end is greater than 0 and s of n minus 1 is so is check, we can have a check function is bad. We can have the function is bad. We can pass two characters, both characters. What we can do is we can pass the characters s of n minus 1 and s of char. So if this is returning me true, then we have to decrement our end index. Else we are going to add that character at the index end. So s of end is equal to s of char. And once we added, we are going to increment our end. So this function is bad is going to return me bool is bad, where I get two characters char ch and char two adjacent characters. I can say name it as char A and char B. And first what we can do is A is equal to 2 lower of A and B is equal to 2 lower of B. I hope this function is there in our C++ and return A is equal to B. If this is equal, then this is a bad case. So we have to remove that character. So let us try to run our code. Okay, we are actually facing some issue. So let us see. Or else instead of doing like this, if A is equal to is upper of, what we basically do is we want to check whether this is equal or whether this is equal. So how can we check this? If is lower of A and is upper of B, then we have one case. Else if is upper of A and is lower of B, then we have another case. Else we can just return false. So what we can do is okay, while one is lower and one is upper, what we can do is we have to check if A is equal to 2 lower of B. So basically we can just return this. If A is equal to 2 lower of B, else return 2 lower of A is equal to the current character B. I hope this should work fine. I have handled all the cases. Sorry, I have missed a semicolon here. Okay, it gets accepted. Let us try to submit our code for all the test cases. I'll just copy and refresh this. Okay, now let us submit our code for all the example test cases. Okay, great, it gets accepted. Let us submit our code. So hope it gets accepted. Hope you are like the solution and let me know in the comments. And one thing what we can observe here is always to be this bad case, one is lower and one is upper and both are same characters, so there should be a same difference for everything that when we observe that. So for this and B, let us try to see out the ASCII characters for A and as well as B. So let us try to get in some index like this, char A and B, character A, and similarly like this, character B. So let us try to see out the statement here, A and A, and we can see out B as well. So we can just eliminate this function and try to run our code. Why I'm doing this is, let us try to check. As you can see this, these are the differences. So let us try to have an absolute difference between a minus a, and similarly absolute difference between b minus b. Why I am doing this is, let us observe a pattern, because everything are same, right? So the difference should be same. So that's why I'm just doing this and seeing. As you can see that for every bad case, the difference between them is 32. So instead of having that function, what we can basically do is, we can check for its difference. So if end is greater than 0 and my absolute difference of my end character s of n minus 1 minus s of current character, if it is equal to 32 itself, it is enough instead of writing that function. So now let us try to run our code. Sorry. Okay, it gets accepted. Now let us submit the code. Okay, gets accepted. So hope you like the solution and understood why I'm using this difference as 32. So let us see in tomorrow's LeetCode Daily Challenge, and then bye.